Welcome, I'm Fabiana, and today you will see how you can create data pipelines in a few steps in YData Fabric. This is my augmentation project, and I've started by adding a data source to my data catalog. In this case, this is a file in a Google Cloud Storage. Based on my data source profiling, I was able to extract a few insights. For example, one of the variables have high correlation between each other, but I was also able to spot that my label is a variable with high imbalance classes. As this is a financial services dataset, and we are here representing transactions with fraud and non fraudulent events, this is an expected behavior. So let's build a data pipeline to explore the best augmentation strategy to mitigate this imbalanced behavior. To build the data pipeline, I've selected a Jupyter Lab as my work environment. As I'll be working mainly in the pipeline definition, I've also selected a lab with low computing resources. But in case you'll be exploring the data in the labs, the computing power must be selected accordingly. To set my pipeline, I'll need to compose the following steps: reading the data, creating an holdout set and profiling it, as I want to make sure this holdout is representative, setting an augmentation step so I can augment the fraudulent events through data synthesis, train a model on my process training set, and last but not the least, evaluate the results against my holdout set. The process of designing the pipeline itself is very familiar for any data scientist. After all, I'm using Jupyter Notebooks and Python to do so. I can use my preferred packages such as scikit-learn, NumPy, and combine them with YData ecosystem features such as the synthesizers, the data profiling, and our connectors. And of course, all this communication is bidirectional between the UI and the labs, which makes the integration even easier. For the pipeline itself, I've produced one notebook that represents each and every step that we have described here. So let's ensemble them. YData Fabric pipelines are powered by Kubeflow. So let's select the Kubeflow pipeline editor. The process of setting the pipeline flow is pretty straightforward. You can just drag and drop to your pipeline editor each and every notebook that you have produced and configure the computation resources for each and every step. For example, here I'm selecting my runtime image, which includes the YData ecosystem features, plus I want those features to run on the CPU. After all, reading my data does not need a GPU as a computational resource. I can select how many CPUs I want to allocate as well as the RAM in case I need something more powerful to read my data. This is highly useful to be able to configure each and every step in terms of computation, because let's say that we have this element where we want to run on top of a CPU, or we want to run on top of a GPU combined with Torch or even TensorFlow. That is possible without the need for anyone to do the configurations on the infrastructure side to make this seamless. I can also augment the computation resource in case this is a step in my process that is more demanding in terms of computation. After setting carefully all my computation resources, I can just connect each and every step and define carefully the outputs that I'm expecting for the steps. Let's say here I have my data set as an output. I can just define data.csv. Of course, I can use instead of CSVs connectors to write my transient states of the data in case I'm dealing with high volumes of data. And after having all these configurations, it comes the time to configure one of my preferred parameters of the pipelines. The global pipeline parameters are configurable environment variables that you can use to control and create several versions of the same pipeline to test out different hypotheses. So let's say that I want, as this is an augmentation use case, I want to control whether the augmentation, for example, will be applied. I can just create my parameter called augmentation, which will behave as an environment variable inside my notebooks. Define this as, for example, Boolean, so I want it true or false, whether I want to augment or not, and use this to control and test the different flows that I want to validate my augmentation strategy against. This is highly flexible. I can create as well, for example, a parameter for the sample size. Of course, sample size is, for example, the number of fraudulent synthetic data events that I want to inject in my training set. I set this as an integer. After all, number of records must be an integer, and I can set the default value between, for example, 0 and any other value like 1000, which was the case I've selected here. Each and every step of my pipeline can output visual elements and visual outcomes. So at while running my pipeline, I can double check the results that I'm getting. These components can very easily be configured through code, so they are very flexible. And for example, in this case, I'm outputting my profile as an HTML file. The pipelines also have a metrics component that can be used to track the metrics of the business that matter to evaluate the success of our data augmentation strategy. In this case, I've decided to use, for example, F1 score, recall, and the ROC score, but you can apply any other metrics and you can set any other metrics programmatically, as the system to set up these elements is code-based, as you can see in this example. For the purpose of this example, I have already a pipeline here created with all the definitions. Let me show you. I have several different output files. I also have defined, for example, file dependencies, which might be any type of input like credentials in a JSON, but in this case, I have a Python file with auxiliary functions for my augmentation strategy, for instance. So this is very flexible, and you can very easily configure it. Now that I have everything configured and I know that all my settings are very well defined, I want to be able to create this pipeline in the UI, and I want to be able to run several experiments. That's what I'm going to do. I just click run, check whether my pipeline name is correct in my runtime configuration, and create my pipeline in YData Fabric's UI. After the successful creation of my pipeline, I know I can now jump into the UI and see how the process is going. Now that I have successfully created my pipeline, I can see that I have a run here. So we can check. In this case, I'm reading my data, so I can see the logs, I can see the details on how the process is going. And as soon as my run finishes, I can have the metrics and all the details per run. And I'm able to compare the different runs results. That's why it is so important to define pipeline global metrics, which in this case I've defined as the F1 score, the recall, or the ROC score. As you can see here, each and every run does store the configuration of parameters that you have set. We have both for example, the augmentation, the sample, the dataset ID used. This is highly useful in case you want to version and track data science experiments, for example, or different strategies of data processing, and check how that impacts a specific metric. Per run and per example, I can also have access to the variables and metrics that I have defined per step that I want to check. For example, in my data profiling, I have set that I want to see the profile of my data so I can very easily access that through the visualizations of the step, and they are specific to the step. For example, I plotted the ratio between the normal and the fraud classes, and I have here the full detail in terms of the variables and the profiling of the data. But of course, let's say that from the UI, I also want to create an experiment and I want to set different parameters for a run. I'm also able to do so. For that, I need to select the pipeline, in this case, or last pipeline created, give it a name, select the experiment to where I want to add this new run. So I'm only able to compare runs that are within the same experiment. And then I can configure the global parameters of the pipeline. In this case, as I said, no augmentation. I'm just cleaning my parameters. Setting start, and off we go. We have a new run here configured. And of course, as soon as it's finished, I can just compare the results and see how it worked for this new strategy or for this new definition of the pipeline. To wrap it up, each and every pipeline can also be created or give origin to recurring runs. These are highly useful processes in case we want to experiment tracking through time. So let's say that we have a data refreshment and we want to keep testing on our augmentation strategy each and every month or every other month. I can set that through my recurring pipelines experiment. So just selecting my pipeline definition, setting in a name, saying augmentation strategy, validation, setting a new experiment because this is a different type of experiment. Let's say I already have my strategy defined, so I just want to be sure that the data refreshment does not change the results. I've created another experiment for that, and I can define the recurrency of that run by periodicity or by a chronological rule. I can also define the start, end dates, several things I can set as a parameter to configure the recurrency of the pipeline. And as expected, I can change the global parameters of my pipeline as well. I hope you have enjoyed this data quality pipelines development tutorial and hope to see you in the next session.